Hello, everyone. Hello, tomorrow. I will take you into a journey in the world, and we're going to start the journey in the forest. You all know, you all happen to walk in the forest, I think, in your lifetime. Great ecosystems that are doing a lot of services for us every day. And this ecosystem, they are also storing a lot of CO2 every day from the atmosphere to the trunks and in the forest itself when it grows. This forest has been studied for hundreds of years, and 30 years ago, more or less, we have invented the carbon offset system to drive credits from the industry to the forest management to protect the future of our forest, okay? And this greenhouse gas emitted by industries, the industries can compensate what they emit by buying credits, carbon credits, in the forest. And then this money can help build a new forest, reforest some lands that we have deforested over the past decades, and in turn protect our environment and give us the resources and oxygen and carbon sequestration that we need to sustain our planet by giving carbon offset certificates to the industry to meet the regulations. If you look at the planet today, you all know that we are living on an archipelago. We are surrounded by ocean. 70% of our planet is covered by ocean. And this ocean, when you are in the sea, you see the surface of the ocean. It's not very deep totally over the world. It's not very deep compared to the size of the planet. And this water, as you see here, is full of life. It hosts something like 80% of the biosphere of the planet. Everything that lives on the planet, 80% lives in the ocean. It hosts billions and billions and billions of organisms. Big one, you know, the fishes, what we fish, you know, the big mammals, dolphins, whales, of course, that we all love a lot. And but there are also a lot of huge microscopic ecosystems. I would say this ocean is really our life support system. Under this water that you see here, you have the biomass. 90% of the biomass is made of microscopic, invisible, barely invisible organisms, okay? And this ocean is under threat over the last 50 years. We heat too much. We all know that we produce too much CO2 in the atmosphere. That leads to acidification of the ocean. We pollute with plastics. We have a lot of impact on this ocean today and since the last 50 years. But in every liter of seawater, you have 10 billion viruses. 1 liter of seawater, 10 billion viruses. You have 100 million bacteria. We can find a lot of microalgae, and we're going to talk about them, this microscopic world, right after. And also we have predators, grazers that eat and feed on this ecosystem. And if you look from space, you can really see these organisms, actually. You can see them if you see them on this blue color in the ocean, on the surface. You have, same as on land, you have the blossom in spring. Here is in Brittany, in France. And you have the blooming and the blossom of the flowers on the land and the trees that is coming soon, I hope. And in the ocean, you have the same. You can see them from space. These are microorganisms. Very, very small guys. This one that makes this kind of blooms is called coccolithophore. We don't really care, but it's a nice name. It's a cocoa bloom. And they are calcifying the skeleton of this organism that is a few microns, very small, but billions and billions of them. You can see that they are calcifying. They take CO2 from the ocean to make their body, and then they are going into the food chain, or they are dying and they are sinking to the bottom of the ocean. So over the last billion years, what you see in Dover or in France, these limestone cliffs, they are mostly made about these organisms that has been divided, exist in the ocean for 2 weeks, 3 weeks, and then they have sank to the bottom of the ocean. From the surface CO2 they have flowed to the bottom to the ocean and stacking, like you see, to build up what we know as limestone. Paris is full of limestone, but all the buildings, the pyramids of Egypt are also made of life that took CO2 from the atmosphere down to the bottom of the ocean, down to the bottom of the surface of the Earth. So this is very, very interesting, but there are not only coccolithophores, there's many types of organisms, many we don't know, actually today. We have some that are making their body with glass, with silicium, silicates. You have a soft one. We have many sizes, shapes, beautiful shapes, by the way. And all together, since 40 years from now, we have studied this chlorophyll, the color, the green color is the chlorophyll of the organisms, of the microalgae, of the forest. And you can see on this sublimation how the ocean is blooming on and off over the years. You can see the seasons. You see this is the winter in the northern hemisphere, summer, the sun comes back, so you can see really the earth breathing and oceans breathing as well. You can see the chlorophyll on the land, of course, but also you can see a lot and a huge ecosystem of algae blooming in the ocean. And of course, these algae, they make oxygen, as any tree and any plants on the land. They produce oxygen and they store CO2. We all learned that at school when you were 12 to 15 years old. We call this photosynthesis. Also, they are eaten. They are really at the base of the food chain. They are the transformer. They use the sunlight and they use the nutrients in the ocean to build carbon matter, to build matter that is then going into the food chain, used by microscopic organisms called plankton, drifting across the ocean like that. Beautiful organisms again. And and this is like Star Wars in the ocean. There is a fight. For the last 4 billion years, you have a fight in the ocean to fight to be the best one to eat the others, not to be eaten, to fight for the access to the nutrients, to develop technologies, genes, mechanisms, processes, life mechanisms and processes, to use this energy and this richness of the ocean for their body and for the evolution. So from the evolution side point of view, from the beginning of the life on the land, on the planet, bacteria, to today, you have seen a huge complexification of these ecosystems. And today we are, with Tara, with my foundation, the non-profit foundation that we have launched 15 years ago, and 40 laboratories around the world, we have developed for the last 10 years a huge survey to try to understand who is living in the ocean, what are the organisms doing, who are they, how are they working on. We have sampled something like 80,000 samples across the world, from the Arctic to the Antarctic, from Pacific to Indian Ocean. We have worked with all the countries visited, of course, something like 60 countries. We have gathered all these organisms, measures carbon export on the ocean. We measured temperature, measured huge data sets, very heterogeneous data set, images, in order to understand a lot of things. And one of the things we would like to question today is how can we understand this carbon sink from the atmosphere to the bottom of the ocean. Today we believe that 40% of the carbon that is stored on the planet is stored by the ocean every day. And we believe that 50% of the oxygen we breathe is produced by the ocean every day. So it's very a life support system that we talk about now. And you see, on this picture on the right, you can see really the carbon dissolved matter used by organisms, grazed, and then died, and then sink to the bottom of the ocean, storing CO2 for ages like that, okay? This is what we try to understand also with the project. We have many questions, of course, but this question is kind of the key, one of the key ones today that we need to understand. And to do so, you have so much data, so much microscopic organisms. We don't even know what they are, who they are. They are not in the database anywhere in the world. You need to develop to use the new sequencing technology, genomics data sets. You produce DNA, you try to understand who is in there by looking at the DNA, not at looking at the microscope. Okay, and then you have so much data arising from this that you really need today the AI to try to help us understand and treat all these data sets in the future. It's huge genomics. We have, to give you a number, over the last 6 years, we published 100 publications, most in science and nature, very top-notch science. From the researchers from the CNRS, from the CEA, from many laboratories around the world. And we discovered and published 140 million new genes. You are all made of 20,000 genes. And we discovered 140 million new genes in the ocean with this project. And this is the beginning, I think. It's going to be more and more coming up in the coming years from now. And of course, this data is huge data sets. They are also all public accessible data. They are published. When we publish a paper, you publish data sets with it. So you have online today, you have access to the greatest database that we have gathered on the ocean. Integrated one, we have images, genomics, you have the parameters of the ocean to try to understand all this relationship going together. And if you look at the ecosystem, on the blue ball, we have bacteria, microalgae, all these organisms that makes the living on the ocean. With genomics, you can see who is there, who is not there, who is always with someone, so who is never with the others. So you can start to do a network analysis, like a Facebook analysis of the ocean microplankton. And you start to see and tackle into that and see, trying to find what are the services and who is making the services, who is making the CO2 capture, who is producing oxygen, who is storing iron. Many questions that you can look at. And also not only who is doing it, but how they do it, which genes. And if you look, for instance, the carbon pump that you can measure the carbon going down to the bottom of the ocean, then you can link these services, this action, to a network of organisms. You can see there are key organisms that are at the center of the nodes, and you can start to understand how this carbon pump is working. This is really the beginning of it. There was a publication in Science, in Nature, last year, for this, on this topic. So we are really starting to see who is doing what and how it works in the ocean. And this is thanks to genomics, high technology, and also to AI images recognitions, automatic recognitions because you have thousands of millions of pictures to treat and to recognize. And also I think we have, out of what we saw, 40% is unknown to us all. So there's a huge richness there for us all to understand. And the idea is really, in the future, to make models. We make models to predict the weather. This is 70 years ago. Since the last 70 years, we pushed data into these models to make them very precise and more precise every day. So we are now trying to make models of these services done by the ocean ecosystems. How this is working? How would it work in the future? Where do we need to protect it really hardly, and where we need to protect it only a few months per year? How can we understand how this ecosystem is working? Is really what we have in mind. And if you look back in the forest, what I told you at the beginning of this forest, where we are able to make models 30 years ago saying if I protect or if I reforest hundreds of acres of forest, I will store X CO2 from the atmosphere to the forest. So you can try to do the same for the ocean ecosystem I talked about. How can we predict in the future that the ocean will store CO2 at this rate or this rate? How can we predict if I protect an area, I could give carbon offset to the industry? So how can I drive a universal model, again, this time on the ocean sequestration? How can I drive funds to protect our planet that give us back a lot of services to make it sure that we can still work and live on the planet in the future as we did over the last 100 years or so. So the idea today, this will take, I think, 10 years time to, at least 10 years time to try to tackle this issue. How to make a model that describes this system I talked about. How can we use such a model to protect our environment and to make tomorrow a better tomorrow with the technology we have in hand today and tomorrow. So I have just a take-home message that for you, the ocean is our life support system. We cannot live without the ocean. There will be no life without ocean. Also without many things also, but the ocean is very key. Ocean ecosystem services are what I talked about. We have no idea who is there. We haven't spent time in the ocean over the last history of the mankind. We have no means. Now we have the means. Now we have the technology to fit into that. So it's time to go there. We need also AI and more trained AI in the future to work on that, on this universal blue carbon, I would say, blue carbon offset models. And of course, we need more data and huge, much more data of this ecosystem in the future. So this is it for me today. I just want to introduce you this afternoon on the planet, and I hope you enjoyed this talk.